Today we are going to read about fossils. Here's just a moment, please, Ethan. You will get one. I'm giving you this, yes, the right one. So look at the picture. What do you see in that picture? What kind of rock do you think that is, Austin?
Sedimentary.
Sedimentary. Why do you think it's sedimentary?
Because I looked it up last night
Mm-hmm.
and I found out that you could see that it was sedimentary because I typed in a question that said, "What does sedimentary rock look like?" And it said, and it responded back to me, "This is what sedimentary rock looks like.
Well, what?
It has stripes."
Stripes. That's very good. And you know what those stripes are?
They're layers.
Very good, Kristen. They're layers. Remember when we talked about
Fishy.
fishy? Remember when we talked about fishy? And fishy was swimming along, remember? Fishy was swimming along. And what happened to fishy? Poor fishy died, remember? And fishy went to the bottom of the lake. And what got washed into the lake and went to the bottom of the cup? What was it, Christian?
Sediment.
Sediment. Okay, and just one layer of sediment get in there? No, it happens.
After over like
A whole bunch,
million
and then it
years
just
and
became
stuff, it just piles on
layers,
top of it
layers,
and
and layers, different kinds of rock,
Mm-hmm.
and
We get
it creates layers,
layers and
different
layers and
colors.
layers over millions of years. And remember, what is it that makes that rock form? Because it's kind of heavy. What was it? Pressure. Just pushes it down and pushes it down and pushes it down and makes it harder and harder until that rock forms. But wait a minute, fishy's still in there. Is fishy still whole? Is his body still whole, Ethan? What happened to fishy?
Decay.
He decayed. Very excellent use of that word, decayed.
And then after
What
there was
decays?
a soft porridge, then there's a hot, then there's a cold, it's a hard bones.
The whole cold hard bones. So all his soft parts. Thank you. That was really good. But no more blurting, sir. So after his soft parts are gone, his skin and his guts and all that, his eyeballs, his bones are left. Now, not every fishy, not every animal that dies becomes a fossil. The conditions have to be just right. So if fishy gets in there and he's covered up by the sediment, if the conditions are just right, his bones will become a fossil and will leave an imprint in the rock. So let's read on our reading passages about fossils. I want everyone to read together. Can you put your finger on the first word, fossils? Can you hold that for just a moment, please? Ready? Here we go. Fossils are the remains of plants and animals. All fossils were formed at least 10,000 years ago. There are two main types of fossils, body and trace fossils. Could you stay with me, Ethan? Fossils can tell us many things about plants and animals from long ago. Body fossils are the remains of a plant or animal's body. For an animal to become a fossil, it would have been quickly buried after its death. Sediments would cover the remains. The parts of the animals that didn't decay would be buried. Those parts are usually bones and teeth. After a long time, the bone would the minerals would replace the bone. The minerals would be hard like rocks. Other body fossils are found in amber, a hardened tree sap. This is usually where we find insects. Okay, stop right there. So it talked about for an animal to become a fossil, it would have to be quickly buried after its death. So fishy comes in, fishy dies. And what would have to come in quickly? Sediment would have to come in quickly. Very good. And the soft parts rot away
then
And
the
what's
hard
left? Those parts are usually bones and what?
Fossils.
Oh, that's what it's.
bones and organs.
No,
Teeth.
it's teeth. Bones and teeth. Bones and teeth. Okay. Thank you,
I thought the
Ethan.
teeth would just stay in the fish when they die. Like,
Well,
isn't it
the
supposed
teeth
to...
are in the bone, are in the jawbone. So the teeth are made out of the same thing as the bone. They're both made out, have a lot of calcium in them.
Like
So
with cows, they'll stay in
What's
whenever they die.
calcium?
that is something it's a mineral that we get from dairy products and things like that, but you can still get calcium. And it gives you strong bones and teeth. So our fish, poor little fishy, has passed away. His soft parts are gone, but his bones and teeth might be left. And the minerals, after a long time being covered up with sediment, and after pressure, at least 10,000 years, could become a fossil. Kind of cool, huh? That would be pretty fun to find. Let's keep reading. Ready? Okay, wait a minute. That was a body fossil. That's if you've seen pictures of like fish bones and dinosaurs. That's a body fossil. I've only seen pictures. So let's read about what trace fossils are. You ready? Find the word trace. Put your finger on it. It's right here. Find trace. You with me? I need you reading with me, Austin, okay? Ready? Trace fossils are the remains of an animal, such as footprints and nests. A mold is the shape of a plant or animal left in sediments. A cast forms when mud or minerals fill a mold. An imprint is a mold of a leaf or other thin. Okay, we are going to read about fossils, and we have about 12 minutes, so let's buckle down and get it done. Ready? We're going to read together in a level 1 voice. Here we go. A fossil is the preserved remains of plants and animals. All fossils were formed at least 10,000 years ago. There are two main types of fossils, body fossils and trace fossils. Both types of fossils can tell us many things about plants and animals from long ago. Body fossils are the remains of a plant or animal's body. For an animal to become a fossil, it would quickly buried after its death. Over time, sediments would cover the remains. Then the parts of the animals that didn't decay, bones and teeth, would be encased in newly formed sediment. After a long time, the bone would slowly decay and water infused with minerals would seep into the bone and replace the chemicals in the bone with rock-like minerals. Other body fossils are found in amber, a hardened form of tree sap. This is usually where we find insects or pieces of plants. Okay, freeze right there. So we're talking about body fossils. So remember we talked about fishy, and fishy was swimming along and fishy died. And fishy gets covered with what? Sediment. But the conditions have to be just right for a fossil to form. It said in there, how old are fossils? They're at least
10,000 years.
At least 10,000 years. So if fishy died 3 years ago, is he going to be a fossil?
No.
So fishy died, and then his body has to get covered in sediment. He has to decay quickly. And so over time, the sediment builds up and builds up and builds up, and what's on top? We've got pressure because it's so heavy. And but over time, all the soft stuff is gone, right? All the skin and guts and stuff is all gone, organs, all that is gone. But the bones are left, bones and teeth. Well, those bones are still decaying, and slowly water, as all that sediment is in there, there's water in there too. The water seeps into the bones as the bones decay and the minerals in the water harden in the shape of fishy's skeleton. So, and that decayed bone, those little teeny bits of bone, are washed away and become what? Sediment. Those are the bits of bones that we're talking about in sediment, sedimentary rock. Very good. So the minerals in the water replace the bone, okay, and become hard, and that's our fossil. That's our body fossil. A body fossil. Just more than you should have those papers. Oh, we had enough. I've got one right here. Hez, do you need one? Right here, honey. So we've got a body fossil is a part of a body. So a plant body, like the whole stem of a plant, the fish. What if it's just the tail of the fish? That would still be a body fossil. A body fossil. Let's keep reading about trace fossils. I'll answer in a minute.
Freeze and break the bones.
If it were that cold, it could, but we're talking way down deep underground.
Oh, and the Earth's core is close to.
And it's hotter. Very good. The Earth's core is hotter. Really good, Riley. Yeah, look at the picture. You can see it in there. You can see way down, there's some skulls way down in there. And the water seeps in with the minerals and replaces the bone. Yes, Miss Elena.
What if a sardine dies? They're too tiny to have organs.
The what?
Sardines.
No, they have them.
Then why do we?
I don't know. That's a good question because I think they're gross. Okay, so we just learned about a body fossil. That is a part of a body, part of a thing. Let's read about trace fossils. Ready? Here we go. Trace fossils are the remains of an animal, such as footprints, eggshells, and nests. A mold is the shape of a plant or animal left in sediments when the rocks are formed. A cast forms when mud or minerals fill a mold. An imprint is a mold of a leaf or other thin object. Okay, so body fossil is a part of a body. A trace fossil is kind of anything else. A footprint, a teeth marks.
So you know how robins lay eggs
Mm-hmm.
and an egg falls out of the nest sometimes and cracks? Would that be a trace fossil of that bird?
I think it would depend on how formed the bird was in the egg. If there was a body in the egg, then I think it would be a body fossil. But if it's just like the egg, the yolk and stuff, then it would probably be a trace fossil, I think. I'm not sure on that. So footprints, a nest, a den, who said teeth marks, it scratches on something, or like maybe a trail where a dinosaur drug its tail, all trace fossils. Okay, so body fossil is the body or the body of the plant. Trace fossils is anything left behind. Yes, ma'am.
Aren't there a place like where you can go dust off dirt and find isn't that called
I don't know. There's a place where you can go dig with archaeologists. There are places like that, yeah. Or paleontologists.
Are we going to talk about how you can know what kind of food they ate?
In our next paragraph. Yes, ma'am, quickly.
In exploration place,
Mhm.
there's this little booth where you can there's a print on a leaf and you can put paper over it,
Mhm.
and then you can take the wrapper out of it
Mhm.
of the marker and go with it.
Mhm. That's kind of like a trace fossil.
There's a test
Yeah.
at the exploration place.
Okay, let's read about paleontologists. This is my reflection on differentiated instruction. First of all, I have to explain my clothing in the video. I'm actually still wearing the shirt I had on in the video. Today we got to wear our school t-shirts to school because our PTO bought all the staff school t-shirts. So that is why I'm wearing just a t-shirt. So sorry about that. And let's see here. In the reflection, How did I differentiate the lesson for individual or distinct groups of students? You'll notice that the video starts over in the middle. Well, my first group was one of my lower reading groups, and my second group was my higher reading group, and we read basically the same reading passage, but one was at a Lexile level of 730, and the other was at a Lexile level of 970. So you can tell the some difference in the reading, not a lot, but you can really tell in the difference of how the students reacted to the reading and their questions and their responses, how the two levels were very, very different. Any challenges that arose related to differentiated instruction, either during planning or implementation, and how I handled those? The planning was very easy because my cooperating teacher provides these levelized reading passages. We're doing a unit on rocks and minerals right now, and the kids are enjoying it a lot. And having these reading passages at the ready and already levelized are wonderful. One thing I do have to really watch out for with the lower groups is they get distracted pretty easily, and they want to go off on stories about how making personal connections, and I saw this and I've done that, and I have to really watch to make sure that they stay focused and on topic that we're learning and not just telling stories. And how will I change my approach in future lessons based on what I learned from this teaching experience? I've really enjoyed doing the teacher station during our reading centers. We do integrated ELA with science and social studies, and right now we're doing a science unit, like I said, on rocks and minerals. And it's a lot of fun, and it's a very efficient way to handle reading and writing and science and social studies all together, because we have a much bigger block of time. We have about 2 hours in the afternoon to integrate all of those subjects, and it works very, very well without segmenting them into separate subjects. And the kids enjoy it because they get to do a craft sometimes and a lot of hands-on activities. They enjoy it a lot, and I enjoy it a lot because they're having fun learning. And how would I change my approach? I noticed in the video that I do go awfully fast especially with the higher groups. I probably would slow down a little bit and check for understanding more. With the lower group, I know I have to go slowly. With the higher groups, I tend to push them a little harder. And I think, seeing in the video, that I think I might be pushing them too hard. I have to remember they're only in 4th grade, and I need to let them be 4th graders, not expect them to have my level of understanding immediately. But yeah, I think you can tell from this video that I'm having a lot of fun, and the kids are enjoying it, and their insight is pretty amazing. I think that's it. Thank you very much.